Assalamu alaikum, this is Professor Muhammad Hassan Khan, and today we are going to start chapter number 11, which is KMV Portfolio Management. In this chapter, we have to cover all these 6 topics, and the most important topic in this chapter, which is distance to default. And as you can see that I have tried to make this chapter as much short as I can, and try to cover the most important topic, which is distance to default, numerical example using the KMV model formula. As you can see, that's this formula is the key element of this chapter, and if you learn this this formula, so you can easily solve all these numericals in this chapter. So before wasting time, just move toward the first topic, which is the objective of this chapter. Like the main objectives are three: to measure the credit risk of a company, to estimate how likely a company is to default. Third objective is to help bank and investors make better credit decisions. This is the small objective. Let's see the introduction of this chapter, which is the KMV Portfolio Management. KMV is a credit risk model that uses market information like asset value and volatility to predict the chance a firm will fail to pay its debt. It helps to calculate how far a company is from going to bankrupt. The main thing is, like, it helps to calculate how far a company is from going to bankruptcy, like how much distance is left for the company for the chance of bankruptcy. Okay, so let's see KMV model. What the KMV model is: this model checks if a company's assets are enough to cover its debt. Again, this model checks if a company's assets are enough to cover its debt. If not, the company may default. If the company assets are enough to cover its debt, if not, the company may default. Okay, it uses asset value. What did it use? It uses asset values, debt level, volatility, and market data to assess risk. Okay, again, let's see what the KMV model is. This model checks if a company's assets are enough to cover its debt. First thing. Second, it says that if not, if the company assets are not enough, so the company may default. Second part, it says that if not, then company may default. It uses assets value. What it use? It uses asset value, debt level, third, volatility, and market data to assess risk. So this is what KMV model tell us. Let's understand what the distance to default is, which is the key and hot topic of our chapter. What is this? So it shows how far company assets are from. Let's talk about how far company's assets are from the default point. It tells to us, okay, the level where it can't pay debts. The thing is, I'm trying to cover all these small definition in very small chunk points so that you can easily understand what I'm trying to explain you and what these definitions are trying to say to us. Okay, distance to default, what's that? It shows how far company assets from the default. Company's assets are from where? From the default point, the level where it can't pay debts. Okay, these are the 3 main important points. DD is if distance to default. DD means distance to default is greater than, so 2. The key elements, the most important part is this, because we are going to use these 3 parts in the numerical to check the value, that how far the company assets are there. So if the distance to default value is greater than 2, so the company asset or the company is in the safe zone, or you can say that very safe, low risk of default. Okay, second part is DD, which is distance to default, is around 1, like it's if its value is greater than 1, like 1.1, 1.2, 1.3, so we can say that, or you can say that 0.9 or 0.8, so it's mean that moderate risk, like it's in medium risk. Third point, if DD is less than 0.5, which is showing us that the company is at high risk, okay, close to default, the company is going to be default. Okay, so again, first point says that if DD, distance to default value, is greater than 2, we can think that we are on safe part, or you can say that it's low risk of default. Around 1, like below or around to the 1, means that it's a moderate risk. Third is, if is DD value is less than 0.5, then we can say that the company assets are at high risk, which are close to and the company is close to the default. Okay, why we use the distance to default? The thing is that why credit risk assessment, we're going to use credit risk assessment for the risk assessment, risk management, predictive power. So due to these three things, or you can say that, or you can also add more things. So this is like to make you people understand, that's why we use distance to default. And also you have clear the why we use, like it shows what it shows how far the company's assets are from the default. Okay, the thing is, number 5th part of our topic, which is default prediction model. What it says is, this part converts the DD, distance to default, into the default probability. Distance to default into probability, like chance. It compares the company's distance to default with past data to find out the chance of default in the next year. What it says that the main part, the highlighted point is over here. It compares the company's distance to default with past data, I can say that past years, to find out the chance of default in the next year. Okay, it's what it's doing. Default prediction model, what it's doing, it compares the company's DD, default, distance to default, with past data to find out the chance of default in the next year. Okay, 6th, conditional transition matrix. What is this? This matrix shows how a company's credit rating might move over time, like it's go up or down, like going from lower risk to higher risk or vice versa. It helps in tracking and predicting credit quality chances. Okay, again read this, conditional transition matrix. This matrix shows how a company credit rating might move over time, like you can say that sometime company's ratings goes up or it goes down. So shows how company credit rating move over time, like from lower risk to higher risk or vice versa. What it do? It helps in tracking and predicting credit quality changes. Okay, this is all. This is you can say that the short theory of this chapter. Now we are moving toward the main part, which is the distance to default, numerical. This is the formula. Distance to default, DD, equals to ln bracket open V upon dp bracket close plus mu minus 1 upon 2 sigma v square. Okay, it's a single value, sigma v. Okay, which is asset volatility, and this whole value is multiplying by t dividing with sigma v into T. Okay, let's see what V is, what dP stands for, what mu stands for, what sigma V square, sigma V stands for, and what T is, and same over here. So you know that DD means distance to default. We have already understand. We can also see over here. Let's see what's ln. Ln is basically used for calculating. If you want to understand what ln used to do, you have to just basically use in the mathematical symbol. We are not going to understand, we're going to learn this what ln do, but the thing is, the main things are V upon GP. What V? Market value of firm's assets. What V is? Market value of the firm asset, value of the asset, market value of assets. What DP? DP is default point. It's not a the Facebook DP. It's like its main thing is that default point, liabilities dues, default point. DP is default point. Mu, expected return on assets, expected return on asset, like how much we going to get return from our assets, risk free rate. Okay, then we have sigma V, and on sigma we have a square. Sigma V, you can say that asset volatility. Okay, which is no sigma V, or if you want to I told in the class that for like if you guys having any kind of you can say that combination, you can like misunderstanding or regarding to the sigma V, only you can write only sigma over here. Okay, remove this V because you going to have little confusion with this. You're going to write the value of V over here, so instead of having kind of confusion or mixing these two things, so just write sigma. Sigma you can understand, which mean asset volatility. Okay, if you are not getting any kind of trouble or something like that, you can you think that you can understand this thing, so you should write over here. Otherwise you should not write V over here. Okay, it depend on you. Sigma V is the one thing, sigma V over here, which mean the asset volatility, and single V, which mean the market value of the firm asset. Don't multiply sigma with V, it's a single value. Sigma V, I'm again saying it's a single value. Bracket close T. What the time is, what the T is, time horizon. In this numerical, T always be equals to 1, so also remove this T. If you're going to multiply or hold the value with 1, so you definitely get the answer 1. Okay, so remove the one T from here. I have also removed this T in the class. Okay, I have only write the formula ln dd equals to ln V upon dp bracket close plus mu minus, and okay, 1 upon 2. If you going to multiply like you can say that divide 1 divided by 2, you get 0.5. Oh, you can also write 0.5 instead of 1 upon 2. Okay, it depend on you. 0.5 or 1 upon 2, or and you can also write sigma square instead of sigma V square. Okay, and divided by sigma, the same thing. It depends on you that you can make this formula short according to your understanding, or you can also write this whole formula. It's the same thing. So let's understand this key point of we have already discussed. If the value of dd is greater than 2, we're going to have the safe zone or the low risk, and dd equals to or around 1 or above, little like 1.2, 1.3, 1.4, something like that, or like 0.8, 0.9. so it means that its value is going to be and at the moderate risk. If you got the value of dd, you got the answer of dd less than 0.5, then you're going to have the high risk. Okay, let's start the numerical. Understand the numerical. A credit analyst is evaluating the financial health of a company with a market asset value of 500 million. The company's asset value, you only have to understand the numerical wordings. Asset value, okay, 500 million. The company's default point, DP, you can understand, based on the short-term debt and half of long-term debt is 300 million. Okay, value that the expected return on the asset is 5%. Expected return on asset, you have to understand, you have to learn this thing to understand the numerical. Expected return on asset, which mean mu. Okay, market value of the firm, V. Okay, these are the things. Market asset value, which is the V. Okay, the company's default point is 300 million. Data, given that the expected return on asset, which is mu, you can see over here, is 5%, and the asset volatility is 20%. Volatility, asset volatility means sigma V or sigma. Determine the firm's distance to default over a 1 year horizon. Horizon means you're talking about the time period. In these numerical, in distance to default, just put in your mind the t value is equals to 1. Okay, what does the calculated distance to default says about the firm's risk to default? Okay, if you got the answer, then you have to compare. If you got the answer greater than 2, mean it's a safe zone, equals to 1, you're near to the 1, your answer, which mean that you have to write this thing, moderate risk or high risk. Okay, I have make this numericals, like I have divided this thing into the 3 cases. Like case 1, this numerical, you got the answer in the safe zone. Second, also in the safe zone. Second case, moderate, you got the answer near to the 1, like you got the answer 1.14. Same numerical of case 2, like you can also see the answer 1.03. If you're going to move toward the case 3, you will definitely got the answer below 0.5, as you can see over here, 0.1, which means it's going to have the high risk. Last, same numerical of the case 3, as you can see, you got the answer of 0.159. So understand first. If you understand the first case, you will easily solve the numerical. V 500, okay, DP, which is distance to default, which is 300, mu, which is, like you can see, which you can also see that expected return on asset, or sigma V. You can also see over here asset volatility, time, distance to default. Simply you have to write the numerical, put the values in the numerical, you will definitely got the answer. I'm not here to solve you while showing, because I am in this laptop, I only have simple calculator and I cannot solve this thing in the simple let's see, scientific calculator. I don't think that we can solve this, and yeah, we cannot solve this. Simple, you have to put this values in the formula and you will got the answer. If you got the answer greater than 2, it means that low risk. Same as it is, you can see the numerical over here, you can take the screenshot and solve this numerical, check the answer. If you got the answer, you can see the answer 2.39. I have solved and try to make you people solve in the class and help many students to solve the value, to put the values in the calculator. So I hope that you guys can easily solve this numerical and put the formula values in the numerical put the values in the formula and simply got the answer. So this is the case number 3. You can also you can see over here the values and simple formula, simply put in the numerical. And if you want to write this numerical, you can take a screenshot of this, and this is the case number 3. You can just see what the formula is, what the points given to you people, and just check your answer. And if you guys getting any kind of trouble while solving the answer, you can just text me or just write a comment or something like that, so I will definitely answer you people. So this is all from this chapter, and you can also see the table. What table is like 2.7 answer, 2.3, 1.4. These are the answers of all these 3 numericals. This is like a value of a value of asset, distance, DP, you can say that, default point, volatility in percentage, expected return, and the risk level, that where it lies. These 2 lie in the safe zone, these 2 lie in the moderate zone, and these 2 lie in the high risk. Okay, this is all from this chapter, and I hope you guys understand this chapter in very easiest way. And I try to make this chapter very easy for you guys, and so that you can learn this chapter, or not only learning you from the not only from the learning point of view perspective, you can also just understand what these topics are trying to explain to us. So thank you very much. This is all from this chapter, and see you in the next chapter. Till then, Allah Hafiz, take care, bye bye.